with partial credit than I could. Trying to get those grades up, not down. But anyways, that doesn't mean if you don't get yours that you're automatically in that category. I don't want to freak anybody out. It could also just mean that I didn't actually grade all 100% tonight. So yeah, a bit of a weird exam. I'm not sure what happened. It looks like some people just ran out of time and other people breezed right through it. So that's unfortunate. Okay, so the homework, the last two problems of the homework, does extra credit. That's focusing on a topic that, again, I thought you guys had been exposed to. Turns out you haven't. I don't think that doing it today will do anybody any good. It's probably a 3-lecture topic, and I don't want to just try to rush through it for the sake of you guys hearing the words. But hopefully some of you guys took advantage of that and got some extra credit and read a little bit of chapter 15 in order to at least see some of those topics before. Next time I teach the class, it'll be in there, but you guys don't have to worry about that. The rest of it was on chapter 10, and that is all stuff that is absolutely fair game for the exam. That's why the homework was due. And so in that spirit, we're not going to go over exam 2. I don't think we need to. I've posted the solutions. But I will take any questions you guys might have had about this homework 8, at least the chapter 10 problems. We're not going to talk about the chapter 15 problems. Yeah?
So when you get the total species or the total site concentration, do you factor that into the K?
You can. You don't have to.
Okay.
I will not take off any points if you leave out the total concentration. The examples I'm going to do some examples from old exams, and in those I'll leave in a total concentration term. Okay. If you fold that into K, as long as you say that you're doing it, indicate with a prime on K, or just say like, K is equal to K times L, then you're fine. Most of the time when you actually see those things written, they're folded into K, and that has to do with the fact that, remember that rate equations can either be derived or observed. When they're observed, you can't separate them from the rate constant. So normally they're just inside of some K observed. Any other questions about homework 8? Okay.
Can we go over the, I think it was 10.4, it was with the graph. And it was like,
Yeah, let me look at it and see. Oh, I've got cell phone pictures. This is going to be fun.
I have the book.
I would like the book. Yeah, this will help. And then any other quicker questions, and then we will go through it. But any other quick things or questions about the exam or grading or anything like that? Because this is the last time we're going to have any time to talk about this kind of stuff.
Have we thought about where the average will be?
No, that's a good question. I'll send out an email, but I pulled up sort of historical grades for the course, and it was looking like probably about 75% of the historical grades have been either A's or B's, so I'm going to attempt to match that. So that doesn't tell you a number, because I don't have the numbers memorized. I went back and for the first exam kind of saw what would the brackets need to be in order to get that distribution, but I don't have that memorized. But again, I'm going to try to match the historical grading, if that answers your question at all. But that does mean that the average is, somewhere in that A to B range, like a high 80 score is, I think, what. Again, it depends on how you do it. I don't know if I'm going to curve the grades or if the brackets are just going to be set by,
So you're making a 66, an 88, right?
No.
The average is a...
Again, I'm probably not going to numerically curve your grades. What I'm going to do instead is I'm going to assign the grade distributions. What number matches what grade in order to get 75% or thereabouts. Does that make sense?
It sounds like curving.
It is curving. I'm just saying that I'm not going to add some arbitrary number to everybody's grades. It won't be an even curve, in other words. If you have a 40 versus somebody else that has an 80, you guys are not going to both get a 20-point bump. The person with the 80 is going to get an A. The person with a 40, I don't know. Well, I don't know how low that distribution went. But no, like again, you know, I think in the first exam, you know, the average was a 67. If you were in the 70s on that first exam, you were sitting at a B in the class. If that makes sense. But again, that's after one exam. We've got 2 more exams that I haven't factored into that, and the homeworks, which are going to hopefully raise average. Any other questions? Yeah. Yeah, we can talk a little bit about Langmuir isotherms. Anything else? Okay. So let's start with that because it kind of comes before Langmuir-Hinshelwood stuff. I think I have those notes still. The last thing I'll point out that's administrative, fill in the faculty evaluations. I'm not saying give me positive reviews, but give me good reviews in the sense that you've thought about what you're putting, you give me something honest. I know it may seem like those things don't matter, that they just go immediately into a dustbin, and I won't lie, in a lot of cases that's exactly where they go. Some tenured faculty member who's been here 20 years, they don't care about what you think of him. Me, on the other hand, they care. They want to make sure that I'm good enough, up to snuff, so to speak, to be granted tenure. It actually does make a big impact in my tenure and promotion. All right, anyways, let's talk about a little bit about Langmuir-Hinshelwood Langmuir adsorption real quick. So if we're considering just a single species that can adsorb to the surface, this isn't, again, we're not talking about kinetics right now. Let's just bring it back to a single species that can adsorb to the surface. We can always write a site balance. And in doing so, we've already made a couple of assumptions, and we're going to make more assumptions as we go through. And we recapped these last time, but we'll put them up here a third. So 1 site per adsorbate. Or maybe I should actually write that a little bit differently. 1 adsorbate per site. And that's reflected in this site balance, right? If I have a total number of vacant sites, which they use CV, even though they use S for vacant sites, if I have a total number of vacant sites, and I know how many adsorb sites there are, adsorb species there are, then I can just take a site balance and the total amount of sites that I have, which is constant, right? This cannot change unless my catalyst is deactivating. Otherwise, the total number of sites, the total number of sites is constant. And so I can always write down that site balance expression. So what I can do with that then is I can examine if I have the rate of adsorption. What will that be equal to if this is an elementary step? Some rate constant. And this rate constant is a little different than the ones that we're typically working with. Times the pressure, or we'll just put the concentration of A, times the concentration of vacant sites. And so then what is the rate of desorption? Again, if this is an elementary step,
K back,
Yeah, we can just put K of desorption
K star.
times the concentration. And you're going to notice, I'll switch back and forth between star and S just to get you guys used to it. Times the concentration of those adsorbed species. And so if I look at the net rate of adsorption, it's the rate of adsorption minus the rate of desorption, which is equal to what?
0. 0.
Why would it be equal to 0?
I thought you said that. Oh no, that's right.
Yeah, that would be true at equilibrium. But away from equilibrium, what would this be? Right? So let's do a couple of things real quick. Let's rewrite the concentration of A is equal to the pressure of A, and then what else do I need up here? And so I can rewrite now that K adsorbed and now that allows me to, instead of having a concentration term here for a gas phase species, that's kind of awkward, I can now put the partial pressure of A. Again, we're going to have the concentration of vacant sites and the concentration